Hello everyone. Today we will be discussing about DNS in computer networks. So first up we have Introduction to DNS. Purpose of DNS. DNS or Domain Name System is a decentralized naming system that is used to translate domain names into IP addresses. It allows users to access websites and other resources on the internet using easy to remember domain names instead of complex IP addresses. Importance in computer networks. DNS is an essential component of computer networks as it enables the seamless navigation and communication between devices and services on the internet. It plays a crucial role in ensuring the availability and accessibility of websites and other online resources. Second is understanding domain names. What are domain names? Domain names are the human friendly names used to identify and locate websites on the internet. They provide an easy to remember address for internet users to access websites. Role of domain names in DNS. Domain names play a crucial role in domain name system, which is responsible for translating human readable domain names into IP addresses that computers can understand. When a user enters a domain name in their web browser, the DNS system resolves the domain name to its corresponding IP address, allowing the user to access the website. DNS in computer networks. Emerging technologies and trends in DNS. DNS is a crucial component of computer network providing the foundation for internet communication. As technology continues to evolve, so too do the technologies and trends that impact DNS. Here are some of the most emerging technologies and trends in DNS. DNS over HTTPs. This is a new protocol that encrypts DNS queries and responses, providing better privacy and security for users. DOH is gaining popularity as more organizations and individuals become concerned about online privacy. DNS-based security. As cyber threats continue to evolve, DNS is becoming an increasingly important target for attackers. DNS-based security solutions such as DNS firewall and DNS-based intrusion detection are emerging to help protect against these threats. DNS caching. As the number of devices connected to the internet continues to grow, DNS caching has become increasingly important to improve performance and reduce latency. DNS caching solutions such as DNS caching proxies and DNS caching servers are emerging into organizations optimize their DNS infrastructure. Next is DNS resolution process. Steps in DNS resolution process. User enter a domain name in the web browser. The browser sends a DNS query to the local DNS resolver. If the resolver has IP address for the domain name in its cache, it returns the IP address to the browser. If not, it proceeds to the next step. The resolver sends a recursive query to the root DNS server asking for the IP address of the top level domain TLD server. The root DNS server responds with the IP address of the TLD server. The resolver sends a recursive query to the TLD server asking for the IP address of authoritative DNS server for the domain. The TLD server responds with the IP address of the authoritative DNS server. The resolver sends a recursive query to the authoritative DNS server asking for the IP address of the domain. The authoritative DNS server responds with the IP address of the domain. The resolver caches the IP address and returns it to the browser. The browser establishes a connection with the web using the IP address. Next is types of DNS records. DNS records are used to map domain names to specific IP addresses or other types of data. There are several different types of DNS records, each serving a specific purpose in the domain name resolution. Common DNS record types. A record maps a domain name to the IP address of a specific server. CNAME record creates an alias for a domain name, pointing it to another domain name. MX record specifies the mail server responsible for accepting email messages on behalf of a domain. TXT record allows domain owners to add arbitrary text to their DNS records, often used for verification or providing additional information. Next is DNS records and their purposes. Records. Records are used to map a domain name to IP address. This is the most common type of DNS record and is used to route traffic to the correct server for a website or an application. CNAME records. CNAME records are used to map a domain name to another domain name. This is useful for redirecting traffic to a different server or website. MX records. MX records are used to map a domain name to a mail server. This is important for setting up email delivery for a website or application. DNS security. DNS SEC. DNS SEC is DNS security extensions, is a set of security measures that add an extra layer of protection to the DNS infrastructure. It uses cryptographic techniques to ensure the authenticity and integrity of DNS data. DNS security helps prevent DNS spoofing and other types of attacks that can compromise the DNS resolution process. DNS over HTTPS. DNS over HTTPS is a protocol that encrypts DNS queries and responses using HTTPs. It adds privacy and security to DNS communication by preventing eavesdropping and tampering. DOH ensures that DNS queries are not intercepted or modified by malicious actors. It also helps bypass DNS-based content filtering and censorship. DNS load balancing, round-robin load balancing, and geographic load balancing. Round-robin load balancing is a technique used to distribute incoming network traffic evenly across multiple servers. In the context of DNS, round-robin load balancing involves assigning multiple IP addresses to a single domain name. When a client makes a DNS request, the DNS server responds with one of the IP addresses in a round-robin fashion, ensuring that each server receives an equal share of the traffic. In geographical load balancing, it is a technique used to direct network traffic based on the geographical location of the client. This technique is particularly useful for organizations with a global presence or distributed server infrastructure. By using DNS, the organization can configure multiple IP addresses for a domain name, each corresponding to a server located in different geographical region. When a client makes a DNS request, the DNS server responds with the IP address of the server closest to the client's location, reducing latency and improving performance. DNS hierarchy and structure. TLDs, top-level domains are the highest level of domain names in the DNS hierarchy. They are last part of the domain name and are separated from the second level by dot. Examples of TLDs include .com, .org, and .net. Root servers. Root servers are the top-level servers in the DNS hierarchy. They are responsible for storing the authoritative DNS records for the entire domain name. There are currently 13 root servers, each located in a different geographical location around the world. DNS monitoring and troubleshooting common DNS issues. Common DNS issues: DNS resolution failure, slow DNS response, DNS cache poisoning. Troubleshooting techniques: check DNS configuration, test DNS resolution, clear DNS cache, monitor DNS performance, implement DNS security measures. Resolving DNS issues: verify DNS server availability, check network connectivity, update DNS records, consult DNS service provider. DNS best practices: configuration, use a reliable DNS provider, optimize DNS caching, security, implement DNS security, regularly update DNS software, performance optimization, minimize DNS lookups, implements DNS load balancing. Thank you. I hope you liked the video. Please like and subscribe to my channel.